Hey everybody, I'm Godoy. Last week you heard me present on diesel engines, so this is diesel engines part 2. Last week I talked about the history of it, cars that I used it before. Now I'm actually going to dive into what makes a diesel engine, more so a diesel engine. Alright, so as y'all know, they use compression to ignite the fuel instead of like your typical gasoline engines. They use spark plugs. And they're also used in everyday equipment. They've been used at PFT. Some of y'all may drive trucks, diesel trucks. And so diesel fuel. Diesel fuel is made in a similar way to gasoline. It has more hydrocarbons, which makes it a little heavier. It's a little more oily, and that gives it a little not similar qualities. It makes it a little different from gasoline. So a brief overview of the diesel cycle. So just like the gas cycle, it is most gas engines are 4-stroke, and so this one works in the same way with the intake stroke. Then you got the compression, your power comes out, and then you get to release the exhaust. So these cycles all use the main equation PV equals MRT, which y'all might know from thermodynamics. That was drilled in our brains by Professor Gontier and other professors that you may have taken. Where pressure is P, your volume is V, R is your gas constant, T is your temperature, where the little m is your mass. So using this ideal gas law and other constants, we're able to mix and match and be able to equate or find temperature versus volume or pressure versus temperature and other things like that. Now, a quick fact is that the ignition temperature, auto ignition temperature, where diesel will auto ignite, is 493 degrees Fahrenheit or 256 degrees Celsius. So these equations up here are all used to find the, what you need to be able to construct a diesel engine. You have your compression ratio, which would be your initial volume over your final volume, which is, in a diesel engine, it ranges from anywhere from 14 to 21 usually. And so your K is your constant that is used throughout all these equations, and it's for your heat capacities, and usually it's about 1.4. So if we use these equations, we can find the different volumes or pressures that we'll use in the air to be able to auto-ignite the diesel, which will then produce our work. The next one. So this is a graph of the diesel cycle. So if you start, it's an adiabatic process, and as you go from 1 to 2, you see on the volume and pressure graph, your volume will begin to decrease and your pressure will increase. This will create our compression ratio. It will also compress the air that doesn't have any fuel in it. It's going to make it hotter, as air compresses, it will begin to heat up. And then once we get to our specific volume that we want, the diesel will auto-ignite. So in these equations, W is your work. It's going to be your work produced. And again, P and V are pressure and volume. So then once the diesel is compressed, then it auto-ignites. It creates your work. It combusts. So when it combusts, you go from 2 to 3, you begin your combustion. And then as you go down from 3 to 4 is when you get your work created. The fuel is basically pushing against the piston to create your work. It drives your wheels. It drives your motor, it drives your crankshafts to be able to spin the wheels and make your car or whatever piece of machinery you have go. So in this process, once it's fully compressed, that's when they spray the diesel in. They spray the diesel in, and that makes it different from gasoline engines, because gasoline engines, it's a fuel-gas mixture. It's an air-gas mixture before, whereas diesel is sprayed in right when it hits the maximum combustion. This allows you to get a higher compression ratio. As you can see the work created. This is your total work created, 2 and 3 and 3 and 4, and that's going to be basically your total power that you create. So, some additional info that y'all need, that I've said before, but I'll say it again, is that diesel engines, because they use compression versus just auto-igniting, as they are heavier, diesel engines are heavier, they have to be built better, they have to be able to withstand the stresses and the pressure and the forces that auto-ignition of a fuel will place upon an engine. But one thing that's good about them is they are reliable, as you see in everyday activity. They are reliable. I guess there's the debate, gas engines, diesel engines, which one's better? And although they may be more expensive and pollute more, they do still have a bunch of good qualities, and most of the environmental regulations that are placed upon diesels now make them less harmful to the environment and make them better for the environment overall. Thank you.
Is there any key advantage of using diesel engine over the petrol engine?
Well, I mean, if you, usually they'll produce more torque, which is one of the pluses of them. Also, yeah, no spark plugs. So if you, I guess, if you don't want as much maintenance on some aspects of it. Besides that, I mean, diesel's a little more expensive than gas, but, so that's just a few.
You said diesel is sprayed. What sprays the diesel?
It has a, what's it called? A fuel injector. A fuel injector will spray the diesel in. And so all diesel engines are fuel injected, whereas gas engines may use carburetors.
Any idea how the injector gets actuated?
I do not know that. Do you know that?
It's a good this thing. I think you should go back and look at it.
Okay.
Any questions?
All right.
Okay,